So now let's look at a demo I've set up where we implement this entire thing end to end. So we start with a worst practice environment where we have no security, and we end up with the desired system where we have everything in place. Okay, so what you see here is the pool server to be. It is a clean out-of-the-box server, which has only a few roles and features already installed, like IIS. I've done this so we wouldn't have to wait for it to install those. And I've initialized this node using an initialization script, which cloned one of my Visual Studio Online repos where I have all my demo scripts in for the moment. And this is server core, but with graphical infrastructure stuff. So I actually have integrating scripting environment on this box. And my intent was to do everything on server core, use VI or some console based text editor, but I practiced a few times and it was really not well, it was not very usable in that manner to demonstrate stuff. So I've ended up with the best in the middle. So okay, let's start off. What you see here is a configuration for a pool server. It will install the DSC servers and will create a web pool service on port 8080, and it will not have a certificate. So it's HTTP traffic, right? So let's do that very quickly. 5. So we generate a MOV file, and now we convert this node into a web pool server. And this is a great web pool server which we can use in our demo environment or in our proof of concept environment, but I wouldn't want to have this even in your development environment, right? Your development is probably a reflection of your production. So those MOV files will have probably production-like data, and you need to do a good job protecting those assets. So this script we're going to skip. Actually, what this script does is going to the PowerShell gallery, downloading all DSC resource modules, installing them on the server, and then package them up into the web pool server module repository. Turns out I'm not using any of them for this demo, so we can skip that because well, we need the time, right? So. Okay, what we're going to do now is we're going to generate a GUID, which will be the configuration ID for a new node. And this node will have the telnet client ensured present by this configuration. And we'll put that on this pool server. Okay, so now it's on the pool server. We have generated a checksum. It's there. Now what we need to do is this client. We need to configure the LCM, so it knows where to contact the pool server. For this, we have this configuration block for the LCM. We use the local configuration manager resource. Why we use this resource and not the V2 syntax is because I found some bugs in the V2 syntax, and I will address those in the slides in a while. So we take a lot of parameters, including the pool server URL and the port and stuff like that, and we're actually configuring that server or that client to target the server using this GUID as the configuration ID, port 8080, and in this case we use the NetBIOS name of the pool server. It's just because I can do that in my demo environment. Of course, normally you would put in FQEN there. So now we have the configuration and the hash table in memory. Let's generate the meta configuration, put up a new sim session with this to be client. Let's have an initial look at how the node currently is configured. The LCM is currently configured. You can see this is an out-of-the-box configuration where it's set to apply a monitor, is in push mode, and I've not adjusted anything yet. And now we're reconfiguring it to target the pool server. If you look again, then now we see that the LCM is configured. And if we look at the download manager custom data, we can see that it's now targeting this pool demo server. If I'm fast enough, I can, no, I'm not fast enough. The node's already converging. If we look again at get, we see here that the LCM state is busy. So the node now actually is installing the Telnet client, which was desired, right? So don't waste time, let's move along as this node converges. We're going to increase security by implementing a website or web server certificate on this pool server. So what we're going to do now is the current situation is we have unencrypted channel and we are in no way possible to validate the identity of the pool server. So now we are in a war zone, right? We probably didn't care about our assets and our security. So we're going to improve on that. We're going to make the first step. Let's put a server certificate in place. Because this web pool server is not part of the domain, we don't have the root certificate in our store yet. So I cannot host a certificate on my web binding of which I do not trust, or which I do not trust myself. So I need to import that certificate. The certificate is in this location hosted. It's the AIA location, and we download that and then we import it. Now we've done that, we are able to request for a new certificate, and the certificate we get from this this URL, which is our web enrollment service. And on that web enrollment service, we actually have made available the web server template. And what we're going to do is we're going to use get certificate on this node with these parameters splatted against it. And we're going to use domain credentials with this password to acquire that certificate. If you look very quickly at how the CA is set up, what you see here is that this is the enterprise CA, so this server is part of the domain. It has a CA role installed, and then it's able to serve three kind of certificate templates at the moment. Those templates are allowed for authenticated users to be enrolled. And as you can see, I have set up some templates with some roles like signature role and encryption role, which we utilize in these demos. Okay, and then we have here IIS, and we have here the default website, which has two web applications, which are the web enrollment services. And also here the CDP website, which hosts the CRL and the certificate files. So let's enroll for a certificate. Now we have a certificate enrolled. If we look at the $cert variable, or the cert variable, I must say, we can see that we captured the object associated with this enrollment. So we have available, for example, the thumbprint now under this variable. What you see here is a new configuration for this web pool server, and now we're going to make it secure, right? Because it says so here, secure. We're reconfiguring to port 443, and we're putting in a certificate thumbprint. This will actually, this actually are the only two changes, and this will make sure that we won't listen on an unsecure port anymore. We will only do secure web pools. So we are converged into that new desired state. Now we need to reconfigure the LCM on the client to target the server on the correct port, and telling it's not allowed anymore to do unsecure connections. So if we put that in memory, then here you see we will configure it with port 443 and allow unsecure connection is false. Put that also in memory. Split it against the configuration. So we have a new metamorph. and still have a sim session again for it. Let's reconfigure the node. So we've done that. And now let's look at the download manager data. So now you see we have HTTPS, we have port 443, and allow unsecure connection is false. So now if we update this configuration, then actually the identity of the web pool server is validated. And in this case, I receive an error. And don't worry, because this error is expected. This error actually tells us, well, not too much, but if we would enable some logging on the node, then we could see that the certificate which was provided by the web pool server, it's not trusted. And why is it not trusted? Because the node doesn't have trust in the root CA because it doesn't know it. It's not in its store. So what we're going to do now is we'll run invoke command against the client, and we're going to also store that root CA certificate into the computer store with trusted roots. So let's do that now. And then again do a pull. Okay, so no changes, but the web session and the communication took place the way we wanted it to, and we actually now validated that we need to have trust in the web pool server. Otherwise, we're not going to pull from it. So great things. Now what we're going to do is we will reconfigure the pool server to require client certificates for authentication. So we set up the server side. Now we need to trust the LCMs coming in. We need to trust those nodes, or else they won't get any of our keys to the castle, right? So they won't get our MOF files. So what we need to do now is we're going to create a new local user on this web pool server, provided with a password, and we need that user so we can create a client certificate mapping against it. And somebody comes in with a certificate, or some service comes in with a certificate is validated, authenticated, is trusted, it will be the part that impersonates into a user, authenticated user, and that user needs to be set up. Next thing we're going to do is we install the components used by IIS to do the client-based authentication, the client certificate authentication. Already installed that, but otherwise it would take 5 to 6 minutes. We're going to override some configuration on IIS part so we can actually configure those settings. And then what we're going to do is we're going to reconfigure the DSC pool server application on IIS to actually require client certificates. So as soon as we require client certificates, then no way anybody can come in anymore without one. So let's do that. Okay, now we've run that. We have all components in place. We can make configurations. What we're going to do now is we're going to enable client certificate mapping authentication. Right here we have making sure that we can configure it, and here we are configuring it. So we will enable it. And we will enable the many-to-one certificate mapping feature. Many-to-one will say that all certificates enrolled by a certain CA, we will map to this one user. The other one is this one-to-one certificate mapping would say that we explicitly map a certificate to an identity. And this is really not manageable in this situation, so we're not going to do that. It's an array of hash tables which we can split against its one commandlet. So let's configure that now. It's done. Next thing we need to do is actually set up the rules and the mapping themselves. So what you see here is that the many-to-one mapping will be based on or will map against this user we just set up. So this local user with this password. So as soon as the certificate is mapped, an impersonation will be done using this account. It's actually what it's stating here. Then we create a rule for the mapping, and we say that every certificate that's been issued by a CA, which has in the subject field a CN common name of the PSDSC CA in this case, will be mapped against this well, will be allowed access, right? So and if the mapping actually occurs, that's for the next rule. Two things are here into play. So we have the string data or the UTF-8 data, which comes with a certificate we do a matching on. I say, but that's not really secure because I can I could set up a CA and actually duplicate that information and we're done. But that's of course not the case because the IIS web server, which has this rule, also needs to really trust certificates coming in by validating the trust chain, right? So it actually needs to have trust in the certificate as well. It's not only rules based on strings in this case. Finally, what we're setting up is a general deny rule for anything else. So if we have trust in, like, say, 30 CAs, and we only want one CA coming in for our MOV files, this will exclude all the rest. So by definition, we do this because the web pool server, the web pool server requires, well, the application pool requires for anonymous authentication to stay enabled. If we disable anonymous authentication for this application, then actually the web application pool will not start anymore. So that's why we add on that deny rule, make it more secure. And we run this, and actually that's it. That's all the extra configuration we need to do. So to better secure this web pool server. So look again at LCM download manager data. So there's no thumbprint in there, right? So this node doesn't have any certificate to offer for this pool server. And if we update now, then we should get a forbidden, right? So IIS is actually actively blocking our access to this pool server right now. So mission accomplished. We do not allow any untrusted nodes anymore to be served MOV files. So great stuff. Now, of course, we need to reconfigure that LCM instance to participate in this entire trust thing. And what we're going to do there is, again, we do an invoke command against this node, and we're going to enroll a certificate based on this template, DC pool client auth. And when it's enrolled, using domain credentials in this case, of course, we actually will return the certificate into our current scope. So let's do that. Well, at least we return the object which belongs to this certificate. So if you look at cert now, then you see actually we have that object in our current scope, and we have access on the thumbprint, and we need that to reconfigure the LCM later on. So another local configuration manager reconfiguration piece. In this case, we're going to add a certificate ID to the download manager custom data, giving the LCM and the web download manager of it a means to actually give up the correct certificate when it's asked to do so. Okay, so let's collapse that. Here you see we will provide that the thumbprint. So let's do that. And let's reconfigure the node. Look at the download manager custom data again. Now you can see we have this certificate ID in place. If we now do an update, then in the KP2 log you would actually see the entire negotiation taking place, and you will see this client certificate being processed by the server side and everything working. So KP2 logging, right? If you're debugging this kind of stuff, also it needs to be enabled. But we've reached our end goal here, right? So the client was able to validate its identity and we trusted it, so now it will be served MOV files. Still no change in the MOV files, so it has nothing to download, but that's not the point here. Final piece, right? The MOV file encryption. We need to be secure with our sensitive data. So there's nothing secure about installing a telnet client. We don't, well, if it would be a telnet server, then we wouldn't want our bad guys to know that, because, right, that's It's terrible just having that on there, but mainly identities, right? Credentials and that kind of stuff we need to encrypt. So we're going to generate a new GUID for a new configuration ID and put some folders and some paths in our variables, which we need to have the public certificate keys. This directory will serve as the public certificate repository for our authoring station. And since we are working here, this also is my authoring station. So what we're going to do now again against the client is we're going to enroll for a new certificate, and this time it's based on the DSC encryption template, and we will provide it with the GUID which we just generated, because I'm matching configuration against encryption certificates. We'll give it the credentials, and once we have it, we will actually convert the public key to base 64, and we will return that to our current scope and capture it in this variable public cert. And we do that because we need that public certificate here on this server, right? Because this is our authoring station, we need the public certificate so we can encrypt everything. So let's do that. And now it's enrolled, and you actually can see here that the base 64 code is returned to us. So now we write that base 64 code out to a file called cert file, and this is the cert file, right? So it's in the repo. It has the GUID.cert. So you actually know that this certificate is matched up against this certain configuration. And if we look at it now, then actually you can see it here again. So it's issued to the configuration ID. Okay. Next thing what we're going to do is actually make it available in our PowerShell session. And what you see, if we run this, we actually now have access on the thumbprint, right? And the subject. So okay, a few things we're going to do now is we will put up configuration data, which is a hash table of arrays of hash tables. We need to use that to provide the correct certificate file for doing the encryption, right? So let's do that. Memory. And now what we're going to do is generate a new configuration called local admin. And it will instantiate a new user with credentials we will provide it and make it a member of the local administrators group. Okay. So this actually needs to be encrypted, right? So finally, we're going to call this configuration, provide it with the correct GUID, provide it with the credentials for the DSC administrator, or for the administrator we're going to configure, and the password. We will put the MOV file on our configuration repository, and we will give it the config data which it uses for the encryption part. So now we have generated that MOV file, generated as checksum. Now let's look at the MOV file. And what you see here now is that the password actually is encrypted. So no clear text here. And good luck if you don't have the private key decrypting this thing. So, but still a lot of clear text content in there, right? So if it actually if your resources are very efficient describing your environment, then you would probably rethink those schema things of those resources to make it less obvious how your environment is set up. Okay, next thing we need to do is reconfigure the LCM on that node, because now it has an older configuration ID which we didn't update. We generated a new one because we wanted to associate an encryption certificate with it. And we will take that ID here. And what you see now is that not only the configuration ID is adjusted, also the encryption cert ID here is actually being configured. So, and we do that using this hash table. And here you see the certificate thumbprint in use for encryption certificate, and this is now the thumbprint for the authentication certificate. Right? Let's put it into memory and generate a meta.mov. We have that now. We still have a session. And now we're going to reconfigure the node. Let's look at it, the LCM configuration right now. Now you can see it has a certificate ID and it has a new configuration ID. So if we update now, then actually what's happening now is we validated the identity of the server side. The server validated the identity of the node side. So both parties trust each other. Then the MOV file is being sent over. The MOV file was encrypted using the public key, which the LCM has the private key part of, and the LCM, because of that, was able to decrypt that content and was able to converge into its desired state. So that was the end of this demo.